So we start with the car giant Tesla. It's raised its spending plans to more than $25 billion.
Something happened on a stage in Texas last week that left the automotive industry scrambling for answers. Elon Musk stepped into the spotlight, held up a small piece of hardware, and within just 48 hours, reports suggested that executives from 3 major automakers had called emergency meetings. One engineer who watched the presentation admitted it made him feel physically sick. Another simply said, "It's over." Not the casual kind of over, but the kind of statement people make in hushed voices when they realize a major shift has occurred. So what exactly was this technology? Why has it created so much concern among Tesla's competitors in the electric vehicle market? And could it really change the competitive landscape overnight? At the same time, Elon Musk has been making it clear that Tesla's future extends beyond cars, with increasing investments in artificial intelligence, robotics, and advanced chip technology. Before the breakthrough for more than a decade, the world's largest automakers have been competing fiercely in a battle many believed would determine the future of transportation. The rise of electric vehicles didn't simply introduce a new category of cars. It reshaped the entire global automotive industry. Throughout much of this transformation, Tesla appeared to be leading the way. But there's an important detail many people forget. In Tesla's early years, few believed the company would remain at the top for long. It was seen as ambitious, innovative, and exciting, but also vulnerable. Compared to established giants such as Ford, General Motors, Toyota, and Volkswagen, Tesla seemed relatively small and inexperienced. These traditional manufacturers had spent decades building massive factories, refining engineering processes, and developing extensive global supply chains. Many industry experts assumed it was only a matter of time before they caught up and pushed Tesla aside. For a period, that prediction seemed reasonable. Competitors began releasing electric vehicles that were stylish, dependable, and practical for everyday drivers. Battery technology improved rapidly, and many analysts started suggesting that Tesla's lead would eventually disappear. Then Tesla introduced something unexpected. It wasn't a new vehicle design, it wasn't a revolutionary battery, it wasn't a software update, it was a motor. And according to reports, engineers who examined the technology quickly reached a startling conclusion. Tesla was no longer just ahead of the competition, it had moved into territory that many rivals simply could not match. What worried competitors most wasn't just the motor's apparent power and efficiency, it was the difficulty of replicating it. Some experts reportedly acknowledged that recreating this technology could take years, perhaps even close to a decade. And by the time competitors caught up, Tesla would likely have moved even further ahead. Why Tesla chose this moment? The timing of the announcement was no accident. Tesla needed a major win. The Cybertruck, once marketed as a revolutionary vehicle that would redefine transportation, had become a growing challenge for the company. Despite years of anticipation and global attention, sales reportedly fell short of expectations. Recent reports suggested that a significant portion of Cybertruck registrations during one quarter came from companies associated with Musk himself, including SpaceX and xAI. Internal purchases appeared to be helping support sales figures. Meanwhile, recalls raised concerns among consumers, and growing competition meant buyers had more electric vehicle options than ever before. Tesla needed something that would shift the conversation, something so significant that the entire industry would be forced to respond. Away from the headlines and public scrutiny, engineers were already working on exactly that. Breaking the rules. To understand why this motor generated such a strong reaction, it's important to understand a fundamental challenge in electric vehicle engineering. For years, automakers accepted what seemed like an unavoidable trade-off dictated by physics. An electric vehicle could be extremely fast and powerful, or it could be highly efficient and capable of traveling long distances on a single charge. Achieving both at the same time has always been one of the industry's toughest challenges. For decades, manufacturers around the world believed this compromise was simply part of reality. Every design decision required balancing performance against efficiency. Tesla's latest breakthrough appears to challenge that assumption, and that possibility is exactly what has captured the attention of the entire automotive industry. For years, the automotive industry believed there was an unavoidable trade-off in electric vehicle design. A car could deliver incredible performance, or it could be highly efficient, but achieving both seemed nearly impossible. Whenever engineers pushed for more power and speed, the result was often a heavier vehicle that generated excessive heat, consumed more energy, and required large cooling systems to keep everything running safely. Meanwhile, cars designed for maximum efficiency often lacked the exciting acceleration and performance that drivers expected. Most automakers accepted this compromise as a fact of life. They believed the limits had already been set by physics. Rather than trying to break those boundaries, they focused on improving existing designs. Tesla, however, took a different approach. Instead of working within the industry's traditional assumptions, Tesla's engineers spent years searching for a completely new solution. Their efforts eventually led to one of the most advanced electric motor designs ever installed in a production vehicle. At the heart of the innovation was a carbon fiber-wrapped rotor. The rotor is the spinning core of an electric motor. As it rotates faster, the forces acting on it become incredibly intense. At extreme speeds, the stress can be so great that the motor's internal components risk deforming, failing, or literally tearing themselves apart. Traditional motor designs struggle to handle these conditions. Tesla's solution was to reinforce the rotor with carbon fiber, a material known for being both exceptionally strong and remarkably lightweight. The carbon fiber layer acts like a protective shell, helping the rotor maintain its shape and stability even under tremendous pressure. The result was a motor capable of spinning at more than 20,000 revolutions per minute, a speed rarely found in everyday passenger vehicles. Performance levels like that are usually associated with specialized industrial equipment rather than family cars. But the real breakthrough wasn't simply the motor's speed, it was its ability to remain stable and efficient while operating at those extreme RPMs. The carbon fiber construction reduced vibration and improved balance, allowing the motor to run more smoothly. This improved stability enhanced magnetic efficiency, meaning a larger percentage of the battery's energy could be converted into forward motion instead of being lost as heat. That advantage is more important than it might seem. In most electric motors, a portion of battery power is inevitably wasted through heat, vibration, and other inefficiencies. Tesla's design significantly reduced those losses, allowing more of the stored energy to be used for actual driving. The benefits were substantial: greater range, stronger acceleration, and lower operating temperatures, all from the same battery pack. Even more important, these gains aren't limited to a single vehicle. Improvements in motor efficiency can enhance every future model built using the technology. The motor delivered instant torque and remarkable acceleration while remaining highly efficient during long-distance driving. It also stayed compact and lightweight, requiring less cooling than many competing systems. That reduced cooling requirement is a major advantage. Cooling systems add weight, increase costs, and occupy valuable space that could otherwise be used for batteries, passengers, or cargo. A cooler-running motor means less complexity and more overall efficiency. While many manufacturers rely on extensive cooling hardware to manage high-performance motors, Tesla's design greatly reduced that burden. The capabilities of this technology became clear when it appeared in the Tesla Model S Plaid. During a demonstration, automotive journalists gathered around a test track expecting a fast launch. What they witnessed exceeded expectations. The Model S Plaid accelerated from 0 to 60 miles per hour in less than 2 seconds. Observers reacted with disbelief as the car launched forward with astonishing speed. Some stepped back instinctively, while others laughed in amazement as they processed what they had just seen. The performance rivaled that of exotic hypercars costing millions of dollars. Yet unlike those specialized machines, the Plaid remained a practical luxury sedan capable of carrying passengers comfortably and traveling hundreds of miles on a single charge. That combination of everyday usability and world-class performance is what made the technology so remarkable. Reports suggest that engineers from rival automakers purchased Tesla Model S Plaids, took them apart in private research facilities, and came away with more questions than answers. The challenge wasn't simply that Tesla's motor performed better, it was that the design was incredibly difficult to replicate. The carbon fiber-wrapped rotor, one of the key innovations behind the motor, presents major manufacturing challenges. Even a small defect in the wrapping process can render the entire component unusable. Tesla had already solved these production hurdles long before many competitors seriously explored similar designs. While much of the industry focused on battery chemistry and vehicle styling, Tesla quietly worked on perfecting the manufacturing techniques needed to bring this technology to mass production. For decades, automakers argued that customers had to choose between performance and efficiency. Tesla demonstrated that both could exist in the same vehicle, and then found ways to make the technology lighter, cheaper, and easier to manufacture at scale. That is where the story becomes bigger than a single motor. Many companies can build eye-catching prototypes and futuristic concept cars. They can generate headlines, attract investors, and create excitement. But producing millions of vehicles efficiently and profitably is an entirely different challenge. This is where Tesla has gained one of its biggest advantages. The automotive industry is filled with examples of companies that promised to revolutionize transportation, but struggled when it came time to scale production. Building a handful of advanced vehicles is difficult enough. Producing millions while maintaining quality, controlling costs, and generating profit is far more complex. Tesla learned these lessons through years of manufacturing struggles. The company dealt with production bottlenecks, automation issues, and factory challenges that nearly derailed its growth multiple times. Those difficult experiences helped Tesla develop expertise that is now becoming a major competitive advantage. Recently, Tesla revealed plans for its next-generation drive units, the family of systems built around its advanced motor technology. These designs are being engineered not only for performance and efficiency, but also for manufacturability, a factor that could play a crucial role in the future of electric vehicles. Tesla's goal is particularly ambitious. The company aims to reduce the production cost of an entire drive unit, including the motor, electronics, and gearbox, to roughly $1,000. That figure is significant because many competitors reportedly spend several times more to achieve comparable performance. Across hundreds of thousands of vehicles, that cost difference becomes enormous. A lower-cost drive unit gives Tesla greater flexibility. The company can reduce vehicle prices, improve profit margins, invest in new technologies, or do all three at the same time. Tesla is also pursuing additional cost reductions throughout its supply chain. Engineers are working to eliminate the need for rare earth materials in future motor designs, reducing dependence on expensive and strategically important resources. The company is also redesigning key electronic components to reduce reliance on costly silicon carbide materials while maintaining efficiency. These efforts could have a major impact on the industry. Rare earth materials have long been considered one of the most challenging supply chain constraints in electric vehicle manufacturing. Reducing or eliminating that dependency would provide Tesla with another significant advantage. Each improvement strengthens the next. Lower production costs can support lower vehicle prices. Lower prices can attract more customers. Higher sales increase production volume, and greater production volume creates additional manufacturing efficiencies. Those efficiencies then help lower costs even further. As a result, competitors are chasing a target that continues to move farther ahead. Meanwhile, many automakers are still struggling to make electric vehicles profitable. Ford has introduced well-regarded electric models such as the Mustang Mach-E and F-150 Lightning, yet reports indicate the company's EV division has faced substantial financial losses. Despite more than a century of manufacturing experience and expertise in large-scale vehicle production, profitability in the EV market remains a challenge. Other companies face similar difficulties. Lucid Motors has developed technologically advanced luxury electric vehicles, but the company has continued to spend cash at a rapid pace while working to expand production and reach long-term sustainability. For many competitors, the challenge is no longer just building a better electric vehicle. It is finding a way to manufacture those vehicles efficiently, profitably, and at scale, the area where Tesla has spent years building its lead. Other electric vehicle startups have faced similar challenges. Rivian generated tremendous excitement and attracted billions in investment, yet its production costs remain high. Established automakers such as General Motors and Volkswagen have also encountered delays, software setbacks, and ongoing concerns about EV profitability. This is what competing with Tesla often looks like behind the scenes. It is not a story of dramatic victories or rapid breakthroughs. In many cases, it is a struggle to reduce losses and improve efficiency while trying to close a widening gap. Among Tesla's global competitors, BYD stands out as one of the few companies capable of challenging it at large scale, particularly in lower-cost markets. However, BYD's biggest strength has been affordability. Tesla's strategy is different. Tesla is not just focused on building inexpensive electric vehicles. The company is trying to create some of the most advanced and desirable EVs in the world while simultaneously lowering production costs. That combination of innovation, performance, and efficiency is what many believe gives Tesla its competitive edge. But this is where the story becomes even more interesting. Many people still view Tesla primarily as a car company. Yet Tesla's real advantage may come from something much larger, a business model that combines multiple industries into a single connected ecosystem. At the center of that ecosystem is technology and data. Every Tesla on the road continuously collects driving information. Each mile driven helps the company learn more about traffic patterns, road conditions, weather, driver behavior, and unusual situations. This data is especially valuable because autonomous driving systems improve through real-world experience. Over the years, Tesla has accumulated one of the largest collections of driving data in the industry, and that advantage grows stronger over time. More vehicles create more data. More data improves artificial intelligence systems. Better AI helps attract more customers, which then generates even more data. This creates a cycle that is extremely difficult for competitors to replicate. Even if rivals wanted to catch up, they would need millions of vehicles on the road collecting information for years. Tesla's advanced drive units play a role in that process as well. Lower production costs and greater efficiency help the company sell more vehicles, placing more Teslas on the road and accelerating the growth of its data advantage. The company's battery business is another key piece of the puzzle. Tesla has invested billions of dollars into battery development and manufacturing because batteries represent the most expensive component in most electric vehicles. Its 4680 battery cells are designed to improve energy density, reduce manufacturing costs, simplify production, and increase overall performance. Many competitors still rely heavily on third-party suppliers for batteries, which means they must absorb additional supplier costs on one of the most expensive parts of every vehicle they produce. Tesla has increasingly focused on controlling more of its own supply chain and technology stack. The company develops its own software, vehicle electronics, computer chips, and power management systems. That approach proved valuable during global semiconductor shortages. While many automakers struggled to secure components, Tesla was often able to adapt more quickly by modifying software to work with alternative chips. This flexibility highlights a key difference between Tesla and many traditional automakers. Tesla often operates more like a technology company that happens to build cars. Its manufacturing strategy reflects that mindset as well. Factories in Fremont, Shanghai, Berlin, and Austin form a growing global production network. Future facilities, including potential expansion into Mexico and India, could help reduce costs further while opening access to major new markets. Each new factory is being designed with large-scale efficiency in mind, helping Tesla bring advanced technologies to mass production. Another often overlooked advantage is Tesla's charging infrastructure. For years, critics treated the supercharger network as little more than a convenience feature. Over time, however, it became one of Tesla's strongest competitive assets. Tesla's charging stations earned a reputation for being fast, reliable, widely available, and easy to use. By comparison, many competing charging networks have faced challenges such as equipment failures, software issues, confusing payment systems, and inconsistent reliability. Drivers have frequently reported arriving at charging stations only to encounter broken chargers, app problems, long wait times, or compatibility issues. As a result, many automakers eventually chose to adopt Tesla's charging standard. Companies including Ford and General Motors announced plans that would allow their customers to access Tesla's charging network, effectively recognizing the strength of Tesla's infrastructure advantage. What began as a supporting feature has evolved into a major part of Tesla's broader ecosystem, one that continues to reinforce the company's position in the electric vehicle market. When you think about it, the situation is remarkable. Tesla's competitors now depend on Tesla's charging network to provide a better experience for their own customers. Every time drivers of rival brands use a Tesla supercharger, Tesla benefits financially. This goes far beyond traditional competition. It reflects the power of a well-developed ecosystem. But the advantage doesn't stop there. Whenever a vehicle connects to a Tesla charging station, valuable information is generated. Tesla gains insights into charging behavior, peak demand periods, regional usage trends, and real-world hardware performance. Even when a customer chooses a competing electric vehicle, Tesla can still benefit through its infrastructure network. This creates a powerful chain reaction. Advanced motors help Tesla sell more vehicles. More vehicles strengthen the charging network. The network generates more data. That data improves Tesla's technology and artificial intelligence systems, and that may be where Tesla's biggest advantage lies. The closer people examine the company, the harder it becomes to view Tesla as simply an automaker. While it builds electric vehicles, it is also evolving into a technology company focused on energy, software, data, and AI. One example of this transformation is Tesla's Dojo supercomputer. Dojo was developed specifically to train artificial intelligence systems using the enormous amount of driving footage collected from Tesla vehicles around the world. Rather than relying entirely on general-purpose computing resources, Tesla designed Dojo to process this information more efficiently and at a larger scale. The importance of this becomes clear when considering how modern AI works. Artificial intelligence improves by learning from massive amounts of real-world data. The more vehicles Tesla puts on the road, the more information its systems can learn from. In a sense, the motor helps put more cars on the road, while Dojo helps transform the data from those cars into intelligence. Many companies in the industry depend heavily on external computing resources, often renting processing power from cloud providers and AI infrastructure platforms. Tesla has taken a different approach by investing in much of its own computing ecosystem. The reasoning is straightforward. Tesla believes its long-term success will depend not only on the vehicles it manufactures today, but also on the intelligence and capabilities those vehicles can deliver in the future. This gives Tesla a unique position. While many competitors must acquire vehicles, collect data, and secure outside computing resources separately, Tesla is attempting to manage all three within a single integrated system. The connection is powerful. Vehicles generate data. Data improves AI. Better AI can enhance future driving experiences and autonomous capabilities. Rather than simply having an early lead, Tesla is building an entirely different competitive model. This creates a cycle that continually strengthens itself. More efficient motor technology lowers costs and improves vehicle performance. Better products attract more customers. More customers put more vehicles on the road. More vehicles generate more driving data. More data helps train smarter AI systems. As those AI systems improve, they can increase the value and capabilities of Tesla's vehicles. Stronger products can lead to greater profitability, allowing the company to invest even more in research, software, computing infrastructure, and future technologies. The result is a feedback loop where each improvement helps drive the next, creating an advantage that becomes increasingly difficult for competitors to match over time. When you step back and look at the bigger picture, it's clear that the electric vehicle race is no longer just about building great cars. Tesla is competing on multiple fronts simultaneously: battery technology, software development, manufacturing efficiency, artificial intelligence, real-world driving data, charging infrastructure, and global production scale. For most competitors, catching up in just one of these areas would require years of investment and effort. Matching Tesla across all of them at the same time is an even greater challenge, one that very few companies are currently positioned to take on. What's remarkable is that many of these advantages connect back to the same source: the motor that was unveiled on stage. It isn't simply another component or product upgrade. It serves as the foundation that strengthens many of Tesla's other advantages. A more affordable and efficient motor leads to lower production costs. Lower costs can translate into more affordable vehicles. More affordable vehicles attract more customers. More customers generate more driving data. More data helps improve artificial intelligence systems. And better AI creates even stronger products in the future. That chain reaction is what makes the technology so significant. Executives across the automotive industry, from Ford, General Motors, Volkswagen, Toyota, Lucid, Rivian, and many others, likely examined the same technology and reached a similar conclusion. The challenge isn't simply that Tesla introduced a better motor. The concern is that the motor supports a larger system of interconnected advantages that competitors may still be trying to replicate. And there is no simple solution. You cannot instantly purchase years of manufacturing experience. You cannot quickly recreate a massive real-world data network. Building an equivalent ecosystem takes time, investment, and execution. Meanwhile, Tesla continues moving forward. This is why the future of the electric vehicle industry may look very different from what many originally expected. Instead of a market where every major automaker competes on equal footing, we may be seeing the emergence of a company that benefits from learning faster, scaling quicker, and connecting multiple technologies into a single ecosystem. In that sense, the motor itself may not have been the real announcement. It may have been a signal, evidence of a broader strategy that extends far beyond vehicle performance alone. Of course, the story is far from finished. The automotive industry remains highly competitive, and innovation can come from unexpected places. The real question is whether Tesla's current lead can be maintained over the next decade, or whether another company will find a way to close the gap. What seems clear is that the competition is no longer centered on a single vehicle or a single technology. It is becoming a contest of ecosystems, scale, data, and long-term execution. and that race is only just beginning.